Hello everybody and welcome. Today we're going to be differentiating between two common terms which are distance and displacement. To do that, let's look at this example. Here we have a cyclist and he is moving on a path. Now let's say that he started from this point, which is 2 meters on this graph. Then he moved to the 10-meter mark. Okay, he moved from the 2-meter mark to the 10-meter mark. Then he turned around, moving from the 10-meter mark to the 7-meter mark. Okay? Now, again, he moved from the 2-meter mark to the 10-meter mark, then from the 10-meter mark to the 7-meter mark. First of all, if I asked you, what is the distance that this man traveled? Well, as you can see, he moved from the 2-meter mark to the 10-meter mark, so this was 8 meters. Then he moved from the 10 to the 7, so this was 3 more meters. In total, the total distance that he moved is equal to 11 meters. So it's quite straightforward and easy. But now, what's the difference between distance and displacement? Now, to understand what displacement means, remember that he started from the 2-meter mark, and let's call it this initial position. So its initial position, or his initial position, was at the 2-meter mark. Then he went to the 10-meter mark, etc., and he ended up at the 7-meter mark. Well, where he ended up is called the final position. I don't care where did he go. The only important thing is that where did he stop? Where is his final position? In this case, we can say that the displacement is the change in movement, and it's found by using this simple equation. It is the final position minus the initial position. This triangle right here means the difference. We're going to use it a lot. This triangle right here is called the delta. Now, when you see the word delta, or you see the term delta, or you see this symbol, it means the difference between something and something. So, in our case, the displacement is the difference between the final position and the initial position. So if we want to find it, the final position was equal to 7 meters and its initial position was equal to 2 meters. So we can say that the displacement is equal to 5 meters to the right. Now we mentioned a direction. That rings a bell, right? What does that mean? Let's go back first of all quickly and summarize what we just saw. The displacement is the change in the position of an object. It's the change in the position of the object. So change again means delta, or this triangle right here. Now, it's the shortest distance. We can also describe it as the shortest distance between the starting point and the ending point. Okay? Now, it's important to know that displacement is a vector quantity, so it needs a magnitude and a direction. That's why when we mentioned the displacement in the example before, we said it was 5 meters to the right on the x-axis, or we can just say positive 5. This means that he's going to the right in the x-axis. Now for distance, the distance is the total length of the path traveled between 2 points, and it is a scalar quantity that only needs a magnitude. Now let's take another example. If somebody asked you to move 3 steps to the left and then move 4 steps forward, okay? And you are asked to find the distance and the displacement. Well, the distance is quite easy. I moved 3 steps to the left, then I moved 4 steps forward. The total distance is equal to 7 steps. It's quite easy and straightforward. What about the displacement? How can I find the displacement? You're going to say it is the final position minus the initial position. But remember here that the displacement is a vector quantity. So adding or subtracting vectors is similar to what we mentioned in the previous video. We called it finding the resultant vector. Okay, displacement is a vector, so I need to find the resultant vector. So to answer this question, let's try to graph our movement. Let's look here. This is the x-axis and this is the y-axis. First of all, we started by moving 3 steps to the right, and then we moved 4 steps forward, okay? Remember that the displacement is the shortest distance between 2 points. So this is our starting point. Right here was from the 0. And this is our ending point right here. Since the displacement is a vector and it is the shortest distance between the start and the end point, we can find it by using the Pythagorean theorem. In other words, finding the displacement is just simply adding vectors together or finding the resultant vector. So quickly we can say that it's equal to 3 squared plus 4 squared, which is equal to 5 meters. So remember, the distance was 7 meters, but the displacement was equal to 5 meters. And this was just a quick introduction to understand the difference between distance and displacement. I hope everything's clear. We will see you in the next videos.